right, so we should be up and I should be recording and we should be good to go. All right, so let's go ahead and date it and do just what we always do. All right, so November 16th. And actually, this is the second part of section 4-3. All right, I think I called this part B, so we'll go ahead and do part B. And then I am, like I said, to shorten tomorrow's lesson a little bit, I'm going to start and do a couple concepts out of section 4-4. All right, now for today, to finish up this 4-3, I want to talk about some right triangle trig. So we're going to go some right triangle trig definitions. All right, now obviously since this is called right triangle trig, this is only going to work when we have a right triangle. All right, these definitions do not work on any other type of triangle. You got to have a right triangle. All right, so I'm just going to draw a generic little right triangle here. It can technically be going any direction that I want. All right, and then I'm going to go ahead and label those vertices. Okay, capital letters if you remember from your geometry class. Okay, now when you deal with right triangle trig, you have to have a reference angle, and that reference angle is going to be one of these two angles. The reference angle is never the right angle. All right, so in this one, let's say I decide that my theta is going to go right here. That's going to be my reference angle. All right, so the definitions are going to be based on that reference angle. All right, so if I switched and I wanted this to be my reference angle, then, because in about 2 seconds here, I'm going to label the sides based on this reference angle. If I switch to this reference angle, then these two sides change because the way you label the sides are in reference to that reference angle. Okay, so if this is my reference angle, we refer to the side that is opposite that angle as the opposite side, and we usually do OPP. All right, this is my reference angle, so the one to the side of it. Now, we all know this is the hypotenuse, so when I say to the side of it, it can't be the hypotenuse side because this has to be the hypotenuse. So then that means this side is the adjacent side. All right, these two over here, the opposite and adjacent side, would change if my reference angle was angle B. Hypotenuse always remains hypotenuse because it's the hypotenuse of a right triangle. All right, so the three that, if you did this in geometry, the three that you did there was sine of theta, cosine of theta, and then tangent of theta. All right, but since we have started this trig unit, we know that there are three other ones. And if you've watched the videos or I've done it in class, the reason I lay these out the way I do is to kind of help you memorize them because there's patterns in all of this. All right, so if I'm going to do my right triangle trig definitions, I'm going to do sine, cosine, tangent. All right, I'm also going to do them in the order of cosecant theta, then I'm going to do secant theta, and then I'm going to do cotangent theta. Okay, so I'm going to do those in that order. All right, so sine, all right, is going to be opposite over hypotenuse. And for right now, I'm just going to write all these out, and then I'm going to show you how you can memorize these. Cosine is adjacent over hypotenuse. All right, and then your tangent is always going to be whatever these numerators are in this order. So opposite over adjacent. Okay, now from here, these are the only three that you have to memorize because of the way that I wrote these. These three over here are the reciprocals of these. So you don't have to memorize them if you know the order in which you're going to write them down. All right, now if you take the first letter of each one of these, okay, there is a story. You can actually look this up on YouTube, but there is a story about a little Indian a lady that stubbed her toe and that sort of thing. If you say these in order, it's like Sokotoa, all right, because there's Toa, Soka, and then there's Sokotoa. All right, so let's write that down. If you're trying to use mnemonics to memorize things, the Sokotoa is kind of cool. All right, otherwise you're just going to memorize it straight. All right, now, like I said, these three over here, all right, are the reciprocals of these, as we've learned in the past, a lot of reciprocals here. So then it's just a matter of rewriting them. So hypotenuse over opposite, hypotenuse over adjacent, and then adjacent over hypotenuse. All right, so we're not, this 9 weeks so far, we've not been taking any memorization quizzes. You've got your reference sheet. These will be on that reference sheet someplace. So in doing your homework, things are going to be a whole lot faster if you do have them memorized. But then again, if you don't and you're using your reference material, then that's fine as well. All right, now let's take a look at what we're going to do. First off, what they're going to do is they're going to give you a right triangle. They may only give you 2 sides. They may not give you all 3 sides, and then ask you to find all 6 trig functions. Okay, so as an example, they are going to be right triangle trigs. So finding a missing side should be a relatively easy way to do that with Pythagorean theorem. Okay, so let's suppose I had a right triangle. And they give you maybe, say, this side is 21. They give you this side as 29. And they put that reference angle right there. They've got to identify somehow where that reference angle is. All right, but they don't give you this. All right, directions would then say find all 6 trig functions. Or they might say it a little bit more fancy, but for the most part, I just want you to find all 6 trig functions. All right, you're going to put your answers in lowest terms. You are not going to use mixed numbers. All right, because you want to see the opposite over adjacent or the adjacent over the hypotenuse. You want to see that form in the triangle. Okay, so the first thing you've got to do is you've got to find that missing side. So step 1, find missing side. All right, and then that's just good old-fashioned Pythagorean theorem, a squared plus b squared equals c squared. All right, so this is my unknown side, so we can call that a squared plus 21 squared equals 29 squared. All right, this is nothing more than some arithmetic here, so you'll square everything out. I'm assuming you're going to use your calculator. I think 21 squared is like 441. 29 squared is like 841. All right, for the most part, these should come out nice. If they do not, you're going to leave them in radical form. Okay, so like when I subtract that, I do get 400. If I take square root of both sides, it would normally be plus or minus, right? But this is a side length, so we only need the positive value. So a equals 20. So this one actually comes out to be a nice 20. Okay, but if this number had not turned out to be a nice square root right there, let's say maybe you might have got, let's switch to different color so you don't think it's part of this problem. If I would have got a equals square root of 5, okay, I would have left it as a square root of 5. Okay, don't try to take that to a decimal. Don't try to simplify. Don't try to do anything with it. Leave it as a radical, and then you would have radicals in your answer. All right, if the radical comes up in the bottom, then you could rationalize. But if the radical's on the top, you would just leave it alone. Okay. All right, so after you do that, all right, I would do the 6 in the order that you memorized them. Do the sine, and then do the cosine next, and then do tangent. All right, and I would actually only work out 3. If you are very confident that you know those 3 and that you're not going to get them wrong, then the other 3 come just from taking the reciprocals. All right, so sine, all right, let's go over here and label the triangle a little bit more. If this is my reference angle, all right, then that means this side over here is my opposite side. All right, this is my hypotenuse side. And then this one, since it's right next to it, has to be the adjacent side. Okay, so sine is opposite over hypotenuse. All right, so I'm going to go ahead and write that so we remember. I'm going to go O over H. Okay, so whatever your O number is, opposite, 21 over 29. I cannot reduce this fraction to lowest terms, but if I could, I would. The only thing I would not do is I would not go to a mixed number. Okay, opposite, or sorry, cosine theta is going to be adjacent over hypotenuse. So I'm going to go A over H. All right, just so we can kind of know the formula there. The adjacent number is 20 over the hypotenuse, which is 29. All right, tangent then is opposite over adjacent. So again, I'm going to use the letters to indicate that. And then numbers would be 21 over 20. All right, again, do not go to a mixed number. All right, now, if you are confident that you have those 3 right, then when you do the other 3, just flip them over. Okay, so cosecant of theta is going to be the reciprocal, so 29 over 21. Secant is going to be the reciprocal 29 over 20, and then cotangent there's going to be 20 over 21. All right, so those are intended to be straightforward. All right, I do know on Math Excel, they're not going to give you all three, because if they give you all three, then it's not a lot of work for you. So that Pythagorean theorem in step one, and then use your formulas to come up with the other ones. All right, now the whole point of having this right triangle trig is, if you're setting it up, we're not going to do necessarily a lot of story problems in this first lesson. We will later on. But you should be able to then use right triangle trig to find missing parts of a triangle. Okay, so that's where we're going to go with this and why you need these types of equations. All right, so let's say that it's directions. Finding missing sides. Or I should say missing anything. It wouldn't necessarily have to be missing sides. I could find other things as well. So finding missing sides is the examples I'm going to do. Let's go ahead and put and angles, because we could get there. And then we're going to say using trig equations that correspond directly to these right triangles. Okay, so to start with, on our first assignment here, you're going to have some right triangles. All right, keep in mind, I don't ever draw these things to scale. All right, they're probably going to give you an angle, say 35 degrees right there. They're going to give you one side, so they might tell you this side is maybe, say, 125. They may give a label on it like centimeters, inches. They may not. All right, and then they're going to put an X someplace. So they're going to start you out with just straightforward, here, find this missing side, find this missing angle, whatever it happens to be. Okay, now what I would do, first of all, is I would take a look at the picture. Okay, so this is 35 degrees. All right, so this obviously is my reference angle. This side over here, in relationship to that reference angle, is opposite. All right, and this one over here is adjacent. All right, that's going to tell you which trig function to use. Do I need to use sine? Do I need to use cosine? Do I need to use tangent? All right, well, which one uses opposite and adjacent is tangent. So that's how I'm going to determine that I'm using tangent as opposed to sine or cosine. Okay, so tangent is opposite over adjacent. Okay, so this right here, just a little thing to remember what the formula is, but I've got an equation, right? So it's the tangent of how many degrees, because whenever you use tangent, sine, cosine, you've got to have a degree in there. So when I write my equation, I'm going to have the tangent of the angle that they give me is equal to, well, opposite over adjacent. My opposite side is X, and my adjacent side is 125. All right, as soon as I have a trig equation like that, then I can work it out. I am going to let you use calculator on this, and we are not going to round, and I'm going to try to zoom in with this and show you how to do that. All right, let's go ahead and solve this using one step. Okay, if I was going to solve for X, what would I do? I'd multiply both sides by 125, right? So I'd multiply by 125, I'd multiply by 125, so those 125s would cross out. So in other words, all right, my X is going to be equal to 125 times the tangent of 35 degrees. Okay, now the fact that I am in degrees right here, the fact that I am in degrees, my calculator needs to be in degrees. Okay, so your calculator needs to be in degrees because the angle is in degrees. All right, and then like I said, you're not in the classroom right now. All right, prior to us going to the virtual, we were in the room, and most of the calculators would have been set to probably radians. All right, now across the top of your calculator, be it whether you're using one by hand or you're using one online, right there it tells you what mode you're in. All right, I've already switched mine to degree. All right, if not, let's go up a little bit, the mode button right there. Okay, you press that mode button. All right, a lot of things come up about the, let's see, 1, 2, 3, 4. The fourth thing going down is radians and degrees. Okay, so if I hit enter, it switches over to radian. If I go to degrees, it switches over to degrees. So this will work, like I said, with the online virtual one that you've been using. All right, but it also works with the ones by hand. Okay. All right, so let's see if I can do a combination of zooming out and zooming in so you can see it. All right, so I don't want you to round this. If I do the tangent of 35 degrees, it's going to be a great big long decimal. I don't want you to round until the very end of the problem. If you remember when you had physics, or if you have taken physics up to this point, all right, they told you don't round until you got to the very end of the problem. So if I just did 125 times the tangent of 35 degrees, I probably wouldn't have even needed to put the time sign in there. I did just to be on the safe side. Okay, and then what's that going to do? Well, that's going to give me a great big long decimal now that I'm at that point. Okay, now I can round that. Okay, pay attention to in my math lab, because I don't know what they're going to ask you to round to. All right, I have no idea, but as you can see, it's a great big long thing. Let's go ahead and move this over. Let's try it again, just out of curiosity. I'm curious to see. All right, I would have got the same thing. I did not need to put that time sign in there. Okay, all right, so let's go ahead and zoom back out. And let's get that in there. Okay, so calculator's got to be in degree mode. So it turned out to be like 87.525942228. All right, that would be the great big long one. If I'm going to round it or estimate it, I might go to 88 centimeters. Again, pay attention to whatever my math lab tells you to do, or Math Excel, I'm sorry, whatever Math Excel tells you to do, round appropriately. All right, so basically that's all there is to this. And I really am hoping that you remember doing this from geometry. You've done this before. All right, let's go ahead and do one more example of that before we move on to something else, just to make sure that you kind of do have it. All right, so let's suppose they can rotate the right triangles. They can draw them any way that they want, and they can put the missing parts anywhere they want. Let's say it's 63 degrees here. Let's say X is here. And then I've got 13 feet here. All right, so again, you're going to start by looking at this angle right here, and then look at the sides that you've got and decide what you've got going on. All right, this one obviously is going to be my opposite side, and this one right here is my hypotenuse. So then again, the question you're going to ask yourself, well, which one, sine, cosine, or tangent, which one of those has opposite and hypotenuse in it? Okay, hopefully straightforward here. You know sine is opposite over hypotenuse. Okay, so that's how you're going to write your equation. Okay, so you're going to come over, you're going to write your equation. If you write sine, then you have to have an angle measure to follow that, because you got to take the sine of something. All right, so it's sine of 63 degrees is equal to opposite over hypotenuse, tells me to put in my x and then 13. Okay, at that point then, I just joined. Okay, so at that point then, what are you going to do? You're going to multiply both sides by x, or 13. All right, so x is going to be about equal to 13 sine 63 degrees. Again, you're in degree mode in your calculator. You're in degree mode in your calculator. Okay, so plug it in, see what kind of great big long decimal you get. You get x is 11.583, something, 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 something. All right, whatever that tells you to round to, that's what you're going to round to. So maybe x is equal to, say, 12 feet on this one, maybe, if they're rounding to the nearest whole number. All right, but I am under the assumption that you did do this quite a bit in your geometry class. Okay, so that pretty much takes care of, pretty much takes care of 4-3, the rest of 4-3. Okay, so like I said, tomorrow is going to be kind of really long, so I do want to touch on just a couple concepts out of section 4-4. All right, so just so that we're noting 4-4, we're starting a little bit early here. All right, so we are going to have to start paying attention to each of the trig functions in each of the individual quadrants and like what their sign is. All right, it's on your reference sheet. It's also, I think it's on there more than once. And depending on how you copied your unit circle down, you may have even added that information to the unit circle. So we're going to take a look at the signs of the trig functions. And initially, the way what they're going to do is they're going to ask you, they're going to do little baby problems with this, all right, just to kind of get you used to playing with this idea. But then later, you're going to have to implement knowing this in working out some of the other problems. And they're not going to tell you that. You're just going to have to be, aware of the fact that, oh, hey, I'm in the third quadrant. So if I write, a tangent answer, it better be positive because I'm in the third quadrant. Okay. So we're going to draw our coordinate plane. Now I am going to set this up to help with the mnemonic here. All right, so I'm going to color code this. This is going to be all functions are positive in the first quadrant. All right, so that A is going to be part of my mnemonic. All right, in the second quadrant, I'm going to have sine and cosecant as the positive trig functions. All right, part of the mnemonic, I'm going to use the T in tangent. So tangent and cotangent are positive in the third quadrant. And part of the mnemonic, I'm going to use the C in the cosine, because cosine and secant are positive in the fourth quadrant. All right, now what I have done here, I've done these letters and colors here so that we can do a mnemonic, okay? So we're going to go, we always go counterclockwise around the circle, okay? The A stands for all students, S, take calculus. All right, not necessarily a true statement. However, a nice little mnemonic that's going to help you remember, hopefully at least the first letter there, okay? So all students take calculus. All right, sine goes with its opposite cosecant, tangent goes with its opposite cotangent, cosine goes with its opposite secant. Okay, now what I've done in this is I've only listed the trig functions which are positive. So that means all other trig functions like cosine, tangent, cotangent are negative. All right, I've only listed the positive ones in each of these, and we're going to base everything on the positive. Okay, now, like I said, to begin with, all they're going to do is they want you to play around with this, and they want you to get used to this. So they're going to ask you just to identify the quadrant in which theta lies, and they're going to give you some clues, and you're going to have to use process of elimination to figure out what quadrant it lies in. Later on, we will do problems that you're going to find, maybe say the cosine value, and it's going to end up in the fourth quadrant. You're going to need to know, well, is that going to be positive or is it going to be negative? Okay, so you'll need to make sure that your answer is positive or negative according to what quadrant it lies in. All right, so initially, I was going to say name the quadrant in which theta lies. Okay, so there's going to be our directions. What they're going to do is they're going to give you two little clues. All right, they maybe tell you that tangent of theta is less than 0. And they might also tell you that the cosine of theta is greater than 0. All right, they're just going to give you two little clues. All right, you're going to take a look at this and you're going to draw some conclusions. Okay, now almost every time this clue is going to lead you to two different quadrants. All right, tangent being less than 0. All right, tangent being less than 0 means that it's what? Means that it's negative. All right, so then you've got to come over here and figure out, okay, well, what quadrants can tangent be negative in? Well, it's not 3 because tangent is positive here. Everything's positive here. So that means I've got two possibilities. It can either be in 2 or 4. So my possibilities are 2 and 4. Okay, it's the only two places where tangent can be negative. Then I'm going to come over here. I'm going to look at this. Cosine of theta is greater than 0. Well, when something is greater than 0, it is positive. All right, so then I'm going to come over here and I'm going to figure out, okay, well, what two quadrants are possibilities? Okay, well, all functions are positive in the first quadrant, so I've got quadrant 1 as a choice. All right, cosine is positive in the fourth, so my other possibility is fourth. All right, now once you do that, okay, something's going to match. This one's negative in the fourth. This one is positive in the fourth. All right, which means then that theta lies in the fourth quadrant. Okay, so those clues led me to be able to deduce where my theta has to lie. Okay, so that's a pretty straightforward problem, not too hard, a little bit of thinking. You'll definitely get two choices here. You'll definitely get two choices here. And then from there, you can draw a conclusion. All right, now, to be able to do this type of problem, this has to be memorized. All right, or you've got to be using your reference sheet, one of the two. It's going to be a lot easier and quicker. If you do more memorizing of the different formulas, it's just going to go a lot quicker when you're working out all the different types of problems. All right, so in section 4-4, I definitely wanted to touch on that because that was a relatively short thing that I could add today, and it was quick. All right, I'm going to add one more thing from tomorrow's lesson because it's relatively short as well. All right, there are these things called reference angles. Now, we did have reference angles in our right triangle that we just did. I believe as I wrote this down, I didn't do it on that page. Let's see, where did I do it? I didn't on the very beginning. All right, I believe that I referred to this as a reference angle. In relationship to right triangles, that is a reference angle, okay? I have lots of reference angles. They're going to refer to a lot of different angles that I need to in each of the different types of problems that I'm going to do. On this particular type of reference angle here, I'm going to give you a specific definition, all right, and then that's going to lead to using that in some of the problems that we do in the future. All right, so as a formal definition here, let's just say a reference angle. It's the positive acute angle theta prime formed by the terminal side. Okay, so that's like from day one of when we started our trig unit, terminal side of theta and the x-axis. Okay, so a lot of important words here. All right, it's the positive, so you gotta have a positive angle. It's going to be acute, and it's the angle that is formed by the terminal side of theta and the x-axis. Okay, that's the definition. Now we're going to draw some pictures so that we can kind of refer to where's our theta prime. All right, and then we're going to do some examples of it. Okay, so let's do this. Let's suppose that my theta goes from here to here. All right, there's my theta. All right, so you're going to have some angle theta. Now, if I want to know what my reference angle is, the reference angle is going to be formed by the terminal side of theta. Okay, well, I started here and I ended up here. So here's my terminal side of theta and the x-axis. Okay, well, and here's the x-axis. All right, so now if I think that's where my reference angle is, all right, I'm going to check. All right, well, yeah, it's going to be a positive value. It is definitely an acute angle. It is created by the terminal side of theta and the x-axis. So this is my reference angle theta prime. Okay, so that's my reference angle. So the idea is relatively simple here. Okay, I'm just going to show you several different scenarios of what it can look like. Okay, let's do another one. Okay, maybe let's suppose that our theta is like really big. Okay, so let's suppose my first angle theta goes all the way around and ends up there in that fourth quadrant. Okay, so that would be a really big theta angle. Okay, so my reference angle is going to be formed by the terminal side of theta. Okay, so all the way around, this is where it ended. So this is my terminal side. Okay, and the x-axis. Okay, well, right there's the x-axis. So I'm going to do that in there. All right, now it should be positive and it should be acute. Well, it's clearly an acute angle. And if I keep going here, it's going to be positive. So that right there would be my reference angle. Now, your reference angle so far on both of these have fallen outside, so to speak, of my original theta. My reference angle can fall on the inside of the original angle. Okay, so just trying to come up with different scenarios here. Okay, all right, my axis just keep getting bigger and bigger and bigger as I go here. Okay, so let's suppose I start and my original theta comes down to this third quadrant. Okay, so I start on the x-axis and I come around to here. Okay, so there's my theta. Okay, now, terminal side of theta. All right, well, this is where it ended. So this is the terminal side of theta. All right, and then the x-axis is right here. Okay, right there's the x-axis. All right, now that's acute. All right, if I keep going in that same direction, all right, it is going to be positive. So my reference angle is inside. My original theta went all the way around to here. My little reference angle then is on the inside of that theta. So there's lots of different places that it can be. All right, now on these I didn't go around more than once, but technically there's nothing that says I can't go around 2 or 3 times. And wherever it ends, the terminal side and the x-axis, that's going to be your reference angle. All right, now what they're going to do, they're just going to ask you to find the reference angle when given theta. That's what they're going to do initially here. All right, so it's going to say find the reference angle. And they're going to give you a theta. Okay, so maybe they're going to give you, say, theta is 345 degrees. Okay, they're going to give you a positive number. All right, now, if you need to draw it, then sketch it. There's absolutely nothing wrong with that. All right, you could just do a nice little rough sketch here. All right, so that you can visualize it. 345 degrees. Okay, well, where's that going to end up? Here's 90, here's 180, here's 270, all the way around is 360. So it's roughly going to be in here, right? So it roughly is coming all the way around to there. Okay, that's my 345 degrees. All right, so if you need to do it to visually see that, and then here's your terminal side, and then here's your x-axis, the question is then how are you going to find this part that's left over right here? Okay, well, 360 all the way around, we went 345, so 360 minus 345, that's going to give me 15 degrees for my reference angle, so theta prime. Okay, so you're going to, add or subtract, or whatever you need to do to figure out how much is left over. Okay, and we haven't done, I didn't do any examples in that first one with negatives, but there's nothing that says that they can't do a negative theta originally. So theta technically could be maybe say negative 135 degrees. All right, again, if you need to, sketch it out so that you can see where that terminal side is in relationship to the x-axis. Okay, keeping in mind what? Negative goes clockwise around the circle. All right, so again, if I start here, here would be 90, here's 180. Okay, so that means it's going to end up here somewhere. All right, and it is important that's going this way, negative 135 degrees. Okay, that might help you visualize it. Okay, well, where was the terminal side? Terminal side's right here. Where's the x-axis? X-axis is right there. Okay, so this time I'm looking for just this amount. All right, well, what am I referencing here? Really, I'm only dealing with half of my circle, right? So that's 180 degrees. So all I need to do is 180 minus 135 to see what's left over, and that's like 45 degrees. So that's going to be my reference angle. Okay. Let's go ahead and do another one just to show you going around multiple times. All right. Let's suppose that maybe say my theta is, I don't know, say 420 degrees. Okay. Again, picture it. All right. I really think that sketching it out is going to help you. All right. 420 degrees is more than one time around the circle, right? So if I start here, I'm going to kind of do a little twirly thing. Okay. So here's one time around 360. Okay. So 360. So if I did 360 plus another 90, all right, that's 450. So I'm not going to go, it won't be all the way up to here. All right, so it's going to go all the way around plus a smudgy bit more. Okay, plus a smudgy bit more, but it's not going to go all the way up there because if I went another 90, I'd be at 450. Okay, so where did it end? It ended in the first quadrant. I'm using the x-axis there. Okay, so then the question is, how much is left over after going all the way around? All right, well, all the way around is 360. I had 420 degrees. I used up 360 of them to go all the way around. I've got 60 left over. So that's 60 degrees right there. So 60 degrees is my reference angle. Oops, that didn't look like it did not look like a prime. So 60 degrees equals theta prime. Okay, so the question is how much is left over? All right, so the reference angles, like I said, some of you are going to be able to do it without doing that little sketch, but that sketch, all right, it just helps you to visualize things. All right, now I did not do any in radian measures. Radian measures are going to be a little bit more challenging. All right, if need be, you can take that radian measure and then convert it to degrees, work the problem out, figure out what it is, and then be sure and take the radian, the degrees and turn it back into radians. If they give you a reference angle in radians, or if they give you your theta in radians, your reference angle answer needs to be in radians as well. Okay, so you're more than welcome to go back and forth between those. All right, at this point in time, I think I'm going to stop sharing.